In this tutorial, we'll learn how to create a halftone gradient effect in Krita by combining a vector gradient with a halftone filter. We're also going to learn a bit about how the halftone filter works. The first thing we're going to do is create a vector layer, and then we'll add some gradients to the vector layer. We've already learned how to create these in a previous video. It's important to make the gradient a grayscale gradient that goes from fully black to fully white. That's because the halftone filter is going to be based on the lightness of each pixel, or more specifically, on the intensity of each pixel. We'll be able to change the color of the effect later. Now that we have our gradients, let's add a filter mask to our vector layer. The filter that we want is in the artistic category. It's called Halftone. For now, we're just going to add it with the default settings to see how it works. Observe that the halftone filter has created a strange pattern in our canvas where we had our gradient previously. If we zoom in, we can see it creates these small dots in a pattern. You may notice that the dots become smaller and smaller closer to the edges of the gradient. In other words, the size of the dots is proportional to the lightness of the pixels in the gradient. Darker areas have thinner dots, while lighter areas have thicker dots. These small dots can look cool when applied as an effect to photos, but they aren't very interesting when we use it with a gradient. Let's try to make them bigger. To do this, first, let's right-click on the filter mask and click on Properties to edit the filter. This filter is very complex with lots of settings, so let's learn them bit per bit. First, let's go to this Transformation tab. Here we'll find a property called Resolution, which controls the size of the halftone pattern. We can drag it to make it bigger. By default, this property uses inches to calculate the size of the pattern. This means it has a different size depending on the DPI of the image, which is the resolution used for printing. This isn't very intuitive for us, so let's click on this button to make it use pixels instead. Now we can drag this size all the way to 100 pixels. 100 pixels isn't the maximum, by the way. If we click on the field, we can type any number we want. Let's make it 200 pixels, for example. This is a bit too big, so I'm going to make it smaller again before we continue. As you can see on the canvas, this halftone effect looks a bit weird. It has squares at the center but creates circles at the extremes. In other words, it makes the gray color become a checkered pattern for some reason. Let's see how we can fix this. On the Screentone Type tab, we can change what halftone pattern is being used to create the halftone. Currently, it's dots pattern and the shape is round, but because the interpolation is set sinusoidal, the round dots are turning into squares. Let's click on this and change the interpolation to linear. As you can see, this makes the dots become circles consistently through the pattern, which looks much nicer. Next, we're going to change the color of the halftone effect. To do this, we need to go to this Post-Processing tab. Observe that there are two Post-Processing tabs in this dialog, which is a bit confusing. We'll see why later. The one that you want to click on is the top one. Here we'll find color buttons that we can click to edit the color of the foreground and of the background. Let's pick some blue colors for our halftone. Although it may be a bit hard to tell, some of the pixels will have a color that is neither the foreground nor the background exactly, but a mixture of the two. Now that we have picked some nice colors and settings, let's try editing the gradient in the vector layer a bit. We can use the control points for vector gradients in Krita to control the halftone pattern, which is really cool and easy to use. This is thanks to the non-destructive filter mask we have applied to the vector layer. If we disable it, we can see that this point is white, this point is black. And when the halftone filter is enabled, one side becomes cyan while the other becomes blue, with a pattern creating the color transition instead of a linear gradient. Next, we're going to learn about the other settings of the halftone filter. The first setting that we have here is the mode. We have the intensity mode, independent channels, and alpha. This refers to where the data comes from that is used to calculate the halftone. In intensity mode, it's probably the intensity component of hue, saturation, intensity, which would be similar to the lightness component of HSL. In alpha mode, it uses the alpha channel of the layer that the filter is being applied to instead. The independent channels mode lets us use different settings for the red, green, and blue channels in the RGB color model. It's also possible to create a CMYK halftone by changing the image color model to CMYK first. None of these other modes are really useful with gradients, so we'll leave this on the intensity mode. In the Post-Processing tab, the next setting that we have is the hardness. This controls how sharp the halftone effect looks. If we move it all the way to 0%, it becomes blurry. Meanwhile, if we make it 100%, it becomes extremely sharp and looks a bit jagged. The default is 80%. This looks sharp in general, but if you look closer, you'll see it's a bit blurry before the halftone effect disappears completely. This happens both on this side close to the cyan and on this other side close to the blue. The next setting we have is this invert checkbox. This setting inverts the foreground and background. More specifically, it inverts the intensity before mapping it to the colors. We'll see in a bit why this detail is important. It's possible to make the halftone effect transparent using the opacity setting. The way this setting works is a bit complicated. If we change the opacity of the foreground, you'll see that the entire canvas becomes filled with cyan, which is the background color. This happens because the way this filter works is by filling the whole canvas with the background color first, and then applying the foreground color according to the halftone pattern. So if we make the foreground transparent, it still draws the background. On the other hand, if we also make the background transparent, it draws nothing. And if we make only the foreground opaque with the background still transparent, then it only draws the foreground. This means that if you want to create a transparent halftone effect, you'll want to change the opacity of the background while keeping the foreground opaque. Observe that with these settings, the circles of the halftone effect are opaque. What if we wanted the circles to be transparent instead, so it looks like circular holes? We can't simply change the opacities, because the background will be drawn on the entire canvas, not only on the areas that don't have circles. In this case, it's possible to achieve the effect we want by checking the invert checkbox. Then the intensity will be inverted before the colors are applied, so what was going to be the background before becomes the foreground and vice versa. Next, we're going to see the settings in the Screen Generator tab. The first setting that we have here is the fill type used with the halftone filter. By default, the halftone filter uses the Screentone fill type, but there are several others. These options are the same options you can find when you create a new fill layer in Krita. Not all of them seem to be very useful. For example, we have a fill type called None that just doesn't seem to do anything at all. It's also possible to use a single color as the fill. The reason this isn't useful is because a single color doesn't have any texture, so the halftone filter applies some sort of change uniformly through the entire canvas. Let's take a look at a useful fill type. We can use the pattern fill type to use a pattern as our halftone texture. This lets us use any pattern that is installed in Krita, which is pretty cool because Krita comes with various patterns installed by default, and you can even install more or create some yourself if you want. Honestly, all of these look pretty cool with this filter. Another option that we have is to use a simple noise instead. In this case, you'll probably want to make it high frequency so it looks very noisy. Or, alternatively, change the X and Y ratios so it stretches horizontally or vertically. Let's set this back to Screentone. Because we changed fill types, Krita forgot the Screentone settings we had before, so I'm going to make it the way it was before and then we can continue. The next setting that we'll see is in the post-processing tab of the Screentone. To understand these settings better, I think we should take a look at how they work with a fill layer first. When we create a fill layer in Krita, we can choose between various fill types. We have the pattern fill type, the simplex noise fill type, and even the Screentone fill type. It's just like in the halftone filter. Even the settings are the same. The only difference is that with a Screentone fill layer, it's always the same pattern through the entire canvas. On the post-processing tab, we will be able to change the color and opacity of the Screentone and to change the brightness and contrast as well. Let's start by making the contrast become 0. If we do this, the pattern disappears and the whole canvas becomes gray. It only becomes gray because the brightness is at 50%. If we make the brightness 0, it becomes black, and if we make it the maximum value, it becomes fully white. Let's see what happens if the contrast is high instead. Now, when we change the brightness, the size of the circles changes instead. Let's go back to the halftone filter. If we make the contrast 0, the pattern disappears just like in the fill layer. We don't want to do that because then there will be no texture. If we make the contrast the maximum value, the halftone effect looks strangely flat. While these settings can seem convenient, it's important to remember that we could just edit the gradient in the vector layer directly to achieve similar effect if we wanted. These contrast and brightness settings are more useful when applying the halftone filter to photos instead of to vectors. Next, we're going to take a look at what we can do in the transformation tab. The first setting that we're going to see here is the rotation angle. This controls the rotation of the Screentone pattern. The default is 45 degrees, which is a bit weird. After all, normally you would expect it to be unrotated by default. Let's see how our dots look like if we remove the rotation. This actually looks very boring compared to the same pattern rotated by 45 degrees. I guess that's why it's rotated by default. Some patterns may look better at some angles, so it's always a good idea to explore these settings. I'll leave the rotation at 0 for now. The next setting we'll see is the size. We've already seen this, but here is something new. If we click on this chain icon, we can set the width and the height of the pattern separately. This means we can make the pattern into ellipses instead of circles, for example. This changes the size of the dots themselves, so when we rotate it, the dots retain the same shape. As you can imagine, there are lots of possible shapes we can create by combining these settings, so we are not going to see all of them in this video. The next setting that we have here is the position. This lets us shift the pattern to one side or another for a given number of pixels. It's actually possible to create a halftone animation in Krita by using a different position setting for each frame. The last setting that we have is shear. This setting is similar to rotation, but it has one secret. With certain values for shear, the Screentone pattern will look completely different because it's stretched thin. Someone creative could probably do something cool with this fact, although it does seem to be a bit random and unpredictable. Let me reset these settings to their defaults. The last setting we have here is for aligning the Screentone to the pixel grid. This only has a minor effect on the pattern, so it's probably not important. Lastly, let's take a look at the settings in the Screentone Type tab. We're going to start from the bottom, this time with the Equalization Setting. This changes how the Screentone pattern is rendered by Krita. In some cases, if it feels like the pattern is being rendered wrong, but you aren't sure why, changing this setting can fix it. However, you generally won't need to touch it, since it still renders the same pattern, only in a slightly different way. Next, let's see what shapes of dots we have. Besides round dots, we also have legacy ellipse, diamond, and square. Legacy ellipse just looks like slightly longer circles. The ellipse shape is very similar but slightly different. There isn't much to say about them. Then we have the diamond and square shapes. These are funny ones. If we click on diamond, Krita is going to render a pattern that looks like squares. This doesn't make sense. We click on diamond, so why are we getting squares? Let's set the shape to square instead. Now Krita is rendering a pattern with diamonds. At first glance it feels like a bug and someone switched them by accident, but this isn't a bug. This is working as intended. Let's select diamond again, which makes squares appear for some reason. Then if we go to the Transformation tab, we'll find that the rotation angle is set to 45 degrees. So these are diamonds, but they are diamonds rotated by 45 degrees, which makes them look like squares. That's very ironic. Let's see what happens if we make the rotation 0. Now it actually looks like diamonds. What about the square shape? Does it look like squares now? Let's take a look. And the square shape does look like squares now too. That's a very confusing consequence of this unusual default value. Let's make it 45 again before we continue. Krita only has two types of Screentones, dots and lines. We've already seen dots, so let's see the line. These lines are diagonal because of the default rotation of 45 degrees. If we go to the Transformation tab again and change the rotation, we can make them horizontal or vertical or anything we want. Like dots, lines also have multiple shapes we can choose from, like sine wave, which makes them zigzag with curves, and triangular wave, which makes them zigzag without curves. Sawtooth wave, which is a bit hard to describe but looks cool. And finally, curtains, which looks more like fish scales than curtains to me. This covers pretty much every setting of the halftone filter, but before the end of the video, there is one last thing to mention. This video was mainly about how to use this filter with a vector gradient, but you don't need to use it with a vector gradient if you don't want to. We can add a new paint layer, use a brush to fill it with black, then use a brush to paint some white on it, and then we drag the filter mask to this paint layer. And the effect is going to be applied to it. Since it's a non-destructive filter, we can even draw on the paint layer after the filter has been applied to create Screentone patterns in real time. This is how to use the halftone filter with vector gradients in Krita. Thanks for watching. Don't forget to like and subscribe, and see you in the next video.